Hello everyone, this is Kalpana here. In this video, we're going to solve a differential equation from higher order linear differential equations with variable questions. So let's get going. Problem solve x square d square minus 4xd plus 6 into y equals to x square plus 2 log x. We are given a differential equation with variable questions. So we are going to reduce this equation to a differential equation with constant question by making some substitution. And also we are given Cauchy's equation. Given Cauchy's equation, x square d square minus 4xd plus 6 into y equal to x square plus 2 log x. Now let's make the substitution. Put x equals to e power z, then log x to the base equals to z for x greater than 0. Let theta equals to d by dz. Here theta is a differential operator with independent variable z. Then xd will be theta, x square d square will be theta of theta minus 1. Now the above equation becomes, replace x square d square by theta of theta minus 1 minus 4 into, replace xd by theta plus 6 into y equal to, replace x by e power z will get e power z whole square plus 2 into, replace log x by z will get 2z, right? Then theta into theta, theta square minus theta minus 4 theta plus 6 into y equal to e power 2z plus 2z, right? Then theta square minus theta minus 4 theta is minus 5 theta plus 6 into y equal to e power 2z plus 2z. So we got a differential equation with constant question. So we have reduced the given differential equation to a differential equation with constant questions, right? And also this is an operator form, sum f of theta into y equals to function of z. Which is an operator form, f of theta into y equals to function of z, where f of theta equal to theta square minus 5 theta plus 6. Now we need to find the general solution to the given equation, which is given by y equal to yc plus yp. Let's now find yc and yp. Firstly, we'll find yc using the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of theta, theta square minus 5 theta plus 6, right? Let's replace differential operator theta by m, so that we'll get f of m equal to m square minus 5m plus 6. Then our auxiliary equation becomes m square minus 5m plus 6 equals to 0, right? Now we need to find roots of this equation. So split minus 5m as minus 3m minus 2m plus 6 equals to 0. Now take m common from the first two terms, we'll get m times m minus 3, and take minus 2 common from the next two terms, we'll get minus 2 times m minus 3 equals to 0. Then m minus 3 into m minus 2 equals to 0, right? Now we equate each factor to 0. From m minus 3 equals to 0, we'll get m equals to 3, and from m minus 2 equals to 0, we'll get m equals to 2, right? Then m equals to 3, 2 are the required roots. So here the roots are real and distinct. Therefore, the roots are real and distinct. We know that when two roots say m1 and m2 are real and distinct, then yc looks like c1 e power 1 root into z plus c2 e power another root into z, right? Now let's write our complementary function. yc equals to c1 e power 1 root into z plus c2 e power another root into z. Now we are having yc in terms of z, but we need to write in terms of x. For that purpose, what we'll do is, we'll write e power 3z as e power z whole cube and e power 2z as e power z whole square. This becomes c1 e power z whole cube plus c2 e power z whole square. Now just replace e power z by x. Then yc becomes c1 x cube plus c2 x square. So this is our required yc. We got yc, now let's find yp. Particular integral. We'll find particular integral using 1 by f of theta into q of z. We have f of theta and q of z, where f of theta is theta square minus 5 theta plus 6 and q of z is e power 2z plus 2z. We can write it as 1 by theta square minus 5 theta plus 6 into e power 2z plus 1 by theta square minus 5 theta plus 6 into 2z. Let's find each term separately. So I'm going to begin with the first term. 1 by theta square minus 5 theta plus 6 into e power 2z. This is of 1 by f of theta into e power az form, right? So we have f of theta, theta square minus 5 theta plus 6. Now compare e power z with e power az. Then for a equals to 2, we'll find f of a, which is equals to f of 2. Just replace theta by 2, we'll get 2 square minus 5 into 2 plus 6. This is equals to 4 minus 5 2s are 10 plus 6, which is equals to 4 plus 6, 10 minus 10, which is equals to 0. So if we replace theta by 2, we'll get 1 by 0 into e power 2z. Since 1 by 0 is undefined, so total term becomes undefined, right? So we cannot replace theta in the denominator. So what we'll do, we'll just find derivative of f of theta. We'll find f dash of theta. This is equals to 2 theta minus 5, right? Now find, okay, this is equals to, write 1z into 1 by, write the derivative of f of theta, that is f dash of theta here. We'll get 2 theta minus 5 into e power 2z, right? Now let's see what happens if we replace theta by 2. We'll get 2 2s are 4 minus 5, which is non-zero, right? Or let's find f dash of 2. This equals to 22 minus 5 equals to 4 minus 5 equal to minus 5, which is non-zero. Always remember that the denominator must be non-zero. Since f dash of 2 is non-zero, so we'll get z into 1 by 22 minus 5 into e power 2z, which is equals to z into 1 by 4 minus 5 into e power 2z, which is equals to z into 1 by 4 minus 5 is minus 1 into e power 2z. We can write it as minus z e power 2z. Okay, this is f of 2. Fine. So this is the result obtained from the first term, which is in z. Okay, later we'll replace yp in terms of x by replacing the results of first term and second term. Now let's go for the second one. You can write it as 2 into 1 by f of theta into z. So this part is of 1 by f of theta into some z power k form, right? Now, take the lowest degree term common from all the three terms, but the first two terms does not have 6, so we'll multiply and divide 6 to the first two terms of denominator. Okay, multiply and divide 6 plus 6 into z is equals to 2 into, now we can take 6 common from the two terms of denominator, we'll get 1 by 6 times theta square minus 5 theta by 6 plus 1 into z, right? Which is equals to 2 into 1 by 6 into, we can write this two terms as 1 plus theta square minus 5 theta by 6 into z, right? Now split this total fraction as 1 by 6 into 1 by 1 plus theta square minus 5 theta by 6 into z. 2 ones are 2 3s are, we'll get 1 by 3 into, and the second fraction is of 1 by 1 plus x form, so we can write it as 1 plus x whole inverse. We can write second fraction as 1 plus theta square minus 5 theta plus 6 by 6 whole inverse into z. Now we can expand this using 1 plus x whole inverse formula, binomial series expansion formula, 1 minus x plus x square minus x cube plus so on. So before applying this formula, we find the derivatives of z. Theta of z is 1, theta square of z is 0, theta cube of z is 0, and so on in general. Theta power k of z is 0 for k equal to 2, 3 and so on, right? Or let's find theta square of z. We can write theta square of z as theta of z. We have derivative of z with respect to z is 1 and derivative of a constant with respect to z is 0, right? Because here theta is d by dz. Okay, fine. Likewise, we'll get theta cube of z and so on are 0. So let's now expand 1 plus theta square minus 5 theta by 6 whole inverse using this formula. We'll get 1 minus of theta square minus 5 theta by 6 plus theta square minus 5 theta by 6 whole square minus plus and so on. Okay, just for x equals to theta square minus 5 theta by 6. Just compare this two. Then for x equals to theta square minus 5 theta by 6, we'll get this expansion. Okay, this equals to 1 minus 1 by 6 into theta square minus 5 theta plus 1 by 6 square into theta square minus 5 theta whole square minus plus and so on, right? This equals to 1 minus 1 by 6 into theta square minus 5 theta plus 1 by 6 square, that is 6, into expand theta square minus 5 theta whole square, which is theta square whole square plus 5 theta whole square minus 2 into theta square into 5 theta, right? This equals to a power m whole power n. Since we know that a power m whole power n is a power m into n. Likewise, theta square whole square is theta power 4 plus 5 theta whole square is 5 5s 25 or 5 square 25 into theta square minus 2 5s are 10. Theta square into theta is theta cube. Okay, we'll get theta power 4 plus 25 theta square minus 10 theta cube minus, plus, and so on. So if you notice, in the third term we are having theta power 4, theta square, theta cube, which involves higher derivatives, right? So we can completely neglect all the terms from here. Okay, from here. Okay, and also in the second term we are having theta square. Since theta square of z is 0, so we can also neglect this theta square from the second term also. Now coming to this is equals to 1 by 3 into expansion of 1 plus x whole inverse is 1 minus x plus x square minus x cube plus so on into z, right? This is equals to 1 by 3 into 1 minus 1 by 6 into theta square minus 5 theta plus 1 by 6 square into theta square minus 5 theta whole square minus so on into z. This equals to 1 by 3 into 1 minus 1 by 6 into theta square minus 5 theta plus 1 by 6 square is 36 into expansion of theta square minus 5 theta whole square is theta power 4 plus 25 theta square minus 10 theta cube minus so on into z, right? Since theta power k of z equals to 0 for k equal to 2, 3 and so on, right? So neglect higher derivatives theta square, theta cube and so on. Okay, theta square, theta cube and so on. So we can neglect all the terms from here and also theta square term from the second term. Then this becomes, or this step becomes 1 by 3 into 1 minus 1 by 6 into minus 5 theta into z. Okay, we have omitted all the terms from here and theta square term from the second term. So we'll get 1 minus 1 by 6 into minus of 5 theta into z. This is equals to 1 by 3 into 1 minus into minus plus 5 by 6 into theta into z. This is equals to 1 by 3 into 1 into zz plus 5 by 6 into theta of z. Since we know that theta of z, value of theta of z is 1. So just replace the value. We'll get z plus 5 by 6 into 1, which is equals to 1 by 3 into z plus 5 by 6. So this is the result obtained from the second term. Now coming to yp. Yp becomes, result obtained from the first term is minus z e power 2z plus result obtained from the second term is 1 by 3 into z plus 5 by 6. Now we are having yp in terms of z, but we need to write in terms of x. So we can replace e power z by x and z by log x. For that purpose, we need to write e power 2z as e power z whole square. Okay. The second term remains the same. Now let's replace e power z by x and z by log x. Then yp becomes minus, replace z by log x, will get log x into, replace e power z by x, will get into x square plus 1 by 3 into, replace z by log x, we'll get log x plus 5 by 6, right? Or we can write it as minus x square log x plus 1 by 3 into log x plus 5 by 6. So this is our required yp. So we got yp and yc. Now let's write the general solution. The general solution is given by y equal to yc plus yp. Then y equal to yc we have c1x cube plus c2x square, and yp is minus x square log x plus 1 by 3 into log x plus 5 by 6. This completes the problem. So we have seen a problem from higher order linear differential equation with variable coefficients in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.